Hi, I'm Andy and welcome to my walkthrough of the 2020 Sans Holiday hack. The objective for this video is to filter out the malicious messages which Jack Frost is injecting into the CAN network on Santa's sleigh. But first we'll help One-Os with a problem of his own to get some extra clues and to develop some familiarity with cans. It's probably not a good idea to be wandering around pretending to be Santa, so let's jump back through the painting on our way. CANs, or Car Area Networks, are the very simple communications networks which exist inside vehicles to allow the various different components to talk to each other. Chris Helge gave a good introduction to the topic at this year's KringleCon. One of the key points was around the data format of CAN messages, which comprise of a message code followed by some data. Up on the roof we find One-Os, who has a log of messages sniffed off of a CAN bus and is trying to find the particular message associated with unlocking car doors. We can view the contents of the log using CAT. The data is organised into 3 columns. The first is the timestamp of each message. The second is the CAN device which the message was sniffed on, and the third is the message itself. This is subdivided into 2 further sections. To the left of the hash is the message type, and to the right of it is the message data. At the moment, we're just interested in that third column, so we can pipe this data through the cut command, splitting on space characters to only be left with only that third column. It would be useful to get a list of all the unique message types so we can analyse each in turn. For that, we need to isolate the message type, which can be achieved by piping through cut again, but this time splitting columns on the hash symbol and retaining only the first column. Then, to get just the unique values, we can pipe through the sort command. We're left with just 3 unique message types, so now we can examine each in turn using grep to filter. There's quite a lot of message type 118, and the data is all the same, so this is unlikely to be the lock and unlock. There's only 3 19B messages, one of which has some different message data. This lines up with One-Os's description of locking the doors, unlocking, and then locking again. We should check the 244 messages just in case, but there's a lot of them with many different values, so probably isn't what we're after. So back to the 19B messages. The unlock is most likely this middle one, so we can submit the timestamp to the run to answer program to verify, and pick up the completion achievement. In return for completing the terminal, One-Os shares some further information about the main objective. The sleigh doors are acting oddly, and the brakes are shuddering. He thinks this is being caused by malicious messages being ejected onto the CAN bus and must be filtered out. However, only Santa is allowed to access the sleigh's CAN systems, so it looks like we'll have to jump through the portrait again, although not before picking up a yellow bulb lying on the floor. We'll need that for the Santa Vator later. Returning back in Santa form, we now have access to the sleigh CAN system. Many CAN messages are whizzing past, and we have an interface to filter out the malicious ones. There's also controls to operate the sleigh, to start-stop the engine, and to lock and unlock the doors. In order to work out which messages are bad and need to be filtered out, we'll first need to work out what each of these message types are related to. A good strategy here is to filter out all of the noisy messages, and through a process of trial and error, determine what does what. Many of these being filtered out are likely to be desirable, but we can always remove or tweak the filter later. Now that there's less noise, it's easier to deduce that message type 02A is associated with the start and stop buttons. Message number 244 seems to be associated with the RPM display, as it changes with the accelerator and the value of the data parameter matches that of the display. 019 seems to be linked to steering, with positive values representing the right direction and negative values representing the left direction. The negative values here are represented in 2's complement form. The brakes are message 080. 19B is related to locking and unlocking, however there does seem to be a spurious value here. And it's not clear what message 118 is related to. Now, recalling that One-Os said that the doors and the brakes were acting weirdly, let's look at each closer in turn. We already spotted something odd looking in the door lock and unlock messages. If lock is all zeros and unlock has the 6th nibble as F, then what's this F2057 about? Chances are this is one of the malicious messages Jack is injecting and will need to be filtered out. Now to focus on the breaks. Messages are constantly generated matching the value of the breaks, but at any value higher than 3, additional messages start to appear. It's not immediately clear whether these values are being interpreted by the breaks in 1's complement, meaning the values are very high, or 2's complement, meaning the values are negative. But either way, the rapid oscillation between values is likely to be causing the juddering one-offs mentioned. Let's remove all the filters and add the 2 that we've identified so far. We'll remove the spurious F2057 value for message type 19B to try and fix the doors. And we'll remove any 080 message where the highest byte is FF to try and fix the breaks. And this seems to do the trick. A Sleigh defrosted message appears along with the achievement for completing this objective. That's all for this video, but leave a comment if you have any questions or if you used a different method for solving any of these puzzles. We'll pick up the story again in part 8, which involves web application hacking and remote code execution. Feel free to take a slight detour on your way and check out some of my other cybersecurity videos, otherwise I'll see you there.